Good morning, everyone. My name is Aiya, and I will present the ruler cannon, a problem from the IYPT contest. So, problem number 7 asks us to investigate the ruler cannon effect and the parameter influencing ejection speed. So, let's begin with a brief of the literature review. First one is the Euler-Bernoulli beam theory that simplifies the bending analysis for long cylinder beams. It had the equation shown below here. And the next one is the potential energy of an elastic beam. Come from stored bending energy and depend on the material property and the deflections. This two theory will help us model the Euler cannon. First, we're gonna represent the Euler cannon with a simple diagram. And then we can identify the key parameter affecting the bending angle and can derive the deflection equation by using the theory that I have said before. Then taking the derivative at the Euler-Bernoulli equation, but the model is difficult to test experimentally. Instead, we're gonna focus on the key parameters. In the static state, in the limits, the minimum applied force for motion is given by this equation, as the red box shown below. And we combine all the model equations. We found five factors that affect the initial velocity. Is there are moment of inertia, modulus of elasticity, friction coefficient, applied force, and applied distance. So this study we're gonna focus on applied distance first. That means the main idea of this experiment is determining the relationship between applied distance, applied force, and the initial velocity at the static limit. And we have used the following equipment for our experiment below here. So the objective is I want to determine the relationship and simplify the physics behind the ruler cannon. And we expect that the force increase with the applied distance and velocity will also increase accordingly. You should remind that the ruler cannon was set up in one force applied toward the cannon. But I hope that the result behavior remain the same. Then we're gonna go to the methodology. First is place the spherical object at the center of the ruler edge, and you can use the marker to mark and help the test. And next one is mark the point where the force will be applied on the ruler with the position ranging from 5 to 15 from the end. Then place the ruler in the front of the photo gate and gradually apply force to the ruler. Once the ball is released, record the maximum applied force and the time taken part to the photo gate. Then we're gonna repeat step 1 to 4 5 times in each applied distance. Finally, we're gonna plot the graph and summarize the preliminary experimental results. So the result we get is the force is increased proportionally with distance, and velocity is increased up to a certain point, then decreased after a high distance of 11 centimeters. That means we can estimate the maximum velocity at a high distance of 11 centimeters. We can explain this event by using the potential energy uh, that's convert into the kinetic energy. By the potential energy is up to force and deflection of the beam. That means maximum potential energy result in maximum initial velocity. So from the velocity graph, we use the data to conduct a small experiment to observe how deflection behaves. At the maximum applied distance, the ruler experiences maximum bending, resulting in the maximum velocity. However, despite the increasing force, a small decrease of deflection can significantly reduce the potential energy. That means deflection has greater effect on the potential energy than the increase of force. In conclusion, applied distance is crucial for the ruler cannon. Force increases with the distance and velocity peak before decreasing due to the potential energy behavior. In the future work, we'll explore more about force and deflection factors that affect the potential energy. And with all of that, thank you all for your attention.